So hi everyone, welcome to my YouTube channel. In this video I am going to explain you about the experiment on attenuation coefficient. So before going to start, if you are new to my channel, please subscribe my channel for. So first you can see here the attenuation coefficient of aluminium for beta particles. So aim is to determine here attenuation coefficient of a given beta source using the aluminium absorber. So apparatus required here are GM counter and then counting system. Then this is beta, here is the source. Beta source bismuth we have used here. Okay, and then these are the aluminium absorbers. So you can see here we have totally selected 10 different thicknesses of the absorber. So here we have marked from 1 to 10. So here I kept source in the source holder, and then this is the absorber I kept above the source. We have to keep the absorber in between the detector, GM tube or GM detector and the source. Okay, so first here we need to understand attenuation. Attenuation means what? The decrease in the intensity of radiation when it passes from the matter. So here we have to find out the attenuation coefficient for given beta source, beta rays, using for aluminium absorber. So just you can read the theory of attenuation coefficient. So here we require some of the formulas to calculate mu by rho, mass attenuation coefficient. So here are the three nature of graphs for this experiment. Operating characteristics of GM counter. Already I have explained how to find out operating voltage in the previous video. So just go to that video. So next graph is for variation of transmitted intensity with axial density of aluminium sample, and then the third graph variation of LAN N versus aerial density of aluminium sample. So these are the three nature of graphs. After doing this experiment you have to plot three graphs. So in the observation you should write down here the operating voltage you have to set, keep the paralysis time 250, and aluminium absorber we already kept between GM counter tube and the source. So this is the absorber we kept here. So next, take the counts for different absorber of varying and keep the source below the absorber. So already we have kept below the absorber. Take the counts for different absorber, vary the counting time of necessary that at least 10,000 counts are recorded for each absorber. So the digits we must get in terms of 10,000, and here as I shown you different thicknesses of the absorber. So total 10 thicknesses. So first one I have kept here in the source holder between source and GMT. So for different thicknesses also you have to take the reading. So next what you have to do, note down the background count. So background count how we have to note down without you should remove this absorber and the source, then you should take the background counts. So here you should remove the source and absorber, then you should take the background counts. So in the part 1, in each of the experiment we have to find out operating voltage. So already I have explained this. So in the part 1 you have to write or determine the operating voltage, GM counter used here, end window GM counter, source used beta source, and duration for the counting. 250 second. So after calculating the operating voltage, you can go to the part 2. So first I will show you how to make the inputs ready here using program key. You have to go to this program key, okay, and as I said, operating voltage. In the first part you have to calculate operating voltage. So already I have explained how to find out operating voltage. So just I kept here 540 for this GM counter. Operating voltage is 540. Then next again go to program, and here 250 paralysis time they have given here. You have to keep paralysis time at 250. So I already kept it 250. Using this arrow key you can change the paralysis time, but for this 250. So as it is I will keep. So background counts you have to take for 900 seconds. So then you have to go to again program key, make it 900 second, and then note down the background counts. So here it is 900 second. Okay, so for 900 second without source you have to take the background counts. So you can see there is no source in this source folder. So then you have to store this data and then start. So you will get the background counts for 900 seconds. So 900 seconds means it will take 15 minutes to complete the reading. So how many counts you will get without source you should write down here. So for 900 second background counts they got about 328. So how much you will get, just you can note down. So for this it will take 15 minutes. So just I have shown you how to take background counts. Then background counts rate you can calculate using this B by T, 900 second. So you will get the background count rate. So after this so because it will take 15 minutes I will go back to program, and here you can go for the tabular column 2, that is for transmitted intensity for different thicknesses of aluminium absorbers. So first you should make ready this tabular column, serial number, areal density of absorber in the increasing order you should take. So as I have given here different thicknesses, you have to find out the areal density of absorber and you should write here. So counting in T seconds, time paralysis time you have to set it for 65 for first reading. So again you have to make changes here. So you should take this 6 and then this you should make 0, then this must be 65. Okay, then already preset time, paralysis time we kept at 250. So say store 540 operating voltage. Then if you next what you have to do, first you should keep the source here in the source holder. Okay, next keep the absorber above the source. So as I showed, bismuth source we have used, beta source. So next you can start, click on start. So you must get the counts in the 10,000 order. So for first reading they kept 65 and they got counts about 10,439, and count rate you can calculate, divide it by 65, 10,439 by 65, you will get count rate. Then net count rate, n prime equal to n star minus n bar. So n star, this one, n bar, that is you can just do this calculation. Then count rate, true count rate, that is n is equal to n prime divided by 1 minus n prime tau. So like that you have to calculate for all the different thicknesses, absorber thicknesses. Here total thicknesses we have given. Just take reading for all those thicknesses. So here n bar is what, background count rate. Just you should subtract here 0.36 in each of the readings. Then you will get this column. So you have to do the calculation for tabular column 2, intensity for different thicknesses of aluminium. So in the tabular column 3 you have to go for LSF method. Here you have to take the column 1, that is areal density D, and then LAN N. So in this tabular column 3, fitting a straight line to the transmission data by least square feet method. So Xi you can take as a areal density, Yi as the LAN N. Then you can go for LSF method. And after calculating, just do the calculation for parameters P, Q, RS, T and Y bar from this tabular column. So next you can calculate slope, then intercept, and then standard deviation, error in slope, error in intercept. So you can do the calculation for linear attenuation coefficient using the slope from LSF method. Mu by rho is equal to minus slope, that you have to put here. You will get mu value, linear attenuation coefficient. Then mass attenuation coefficient, mu by rho is equal to minus slope. Okay, mu by rho, as you know. Then you will have mass attenuation coefficient. Error in attenuation coefficient you can calculate using formula. Then theoretical mass attenuation coefficient. Then you can write the result here: slope, intercept, experimental linear attenuation coefficient, and experimental mass attenuation coefficient, theoretical linear attenuation coefficient. So here are the 3 graphs you have to plot. One is for operating voltage, applied voltage versus counts. So another graph, that is transmitted intensity versus absorbed thickness. And the last graph, that is LAN N versus D. So these are the 3 graphs you have to plot.